Hey there, my fellow intellectuals. How are you doing today? Kyle here with another video, and today what I'm going to be talking about is my coursework and my grades as a PhD student at the University of California, Irvine in the Physics and Astronomy department. Now, if you recall a few months ago, I actually made a similar video to what I'm about to do now, where I talked about my undergraduate coursework for my physics major and my applied math minor. So I thought I would do something similar to that with grad school. Now, there are a few differences between undergrad and graduate courses, so I want to lay that out before I keep going. One of the main things is that to stay in graduate school, at least in our program, you have to maintain a 3.0 GPA or better, which means you really can't afford to get anything lower than a B in these courses, and you're going to be taking them with other highly motivated students like yourself, and so the competition is a bit tougher. In my case, this was sort of balanced out by the fact that the courses were curved, in the sense that the grades were really dependent on how everyone did. So for example, if someone who had the highest score had an 85%, then perhaps an 85% is the mark to get an A plus or something like that, as opposed to being maybe a B or something in a traditional course. So the course grading is really dependent on how everyone does. And so that's one thing that I think is a bit different than it was in undergrad, because in undergrad you have more classes, and then the averaging out turns out to become maybe more closer to a traditional grading scale. But that's just my experience. Another important point to make is that for physics PhDs at UC Irvine, we all take the same core physics classes our first quarter before we transition into our specialty courses. Now, as some of you know, I am an astrophysics specialist, I guess. I study astrophysics, so you're going to be seeing the track for an astrophysics PhD student. Now, I will say that the curriculum has changed a little bit since I've been here at UCI, but nonetheless, I'm still just going to show you the track that I was on and my experiences. So without further ado, let's go ahead and take a look at my transcript, shall we? Okay, so we're looking at a very highly edited version of my transcript here, where I've essentially blocked out all of the information that isn't really relevant. And you can see the term I took the course, the name of the course, and then the grade I ended up getting in that course. So how I'm going to do this is that I'm going to go through each of these courses in order and just tell you about my experience in them. I wrote down a bit of notes for each of the courses just so I can remember, because it has been a while, like 2017 fall quarter. It's been like 3.5 years now. And yeah, that's essentially the format of this part of the video. So it may look like in the fall of 2017 I took 5 courses, but that is actually false. I only took the last 3 on this list that quarter. The top 2 you see here were taken in the summer of 2017, but for some weird reason they had to be put on the fall quarter transcript. So it looks like I did really good the fall quarter, better than I actually did, but that's not true. These 2 courses were in the summer. And they were in the summer because I was in this program known as the Chemical and Materials Physics program, which is up here, but you can see that I actually switched out of it in the following quarter, in the winter of 2018, because that's when I decided to switch into astrophysics. I made a whole video about that on my channel before, so I highly recommend you checking that out if you want to know why. And so these 2 courses were actually for the Chemical and Materials Physics program, and the Laboratory Skills class was essentially a class that focused on this program known as LabVIEW, which is like a graphical programming language software class where you can design like virtual experiments and stuff. So we did a number of experiments where we built like a lock-in amplifier to see how far we could measure like an LED signal. We also made like an Arduino radar sensor, which was also pretty cool. And overall, it was super interesting. I think as someone who doesn't do experimental work anymore, I have mad respect for people who do. Honestly, my ergonomic skills are really not up to snuff, I think, compared to people in this class, because some people were they could just do it like that. Like they just knew exactly which wires to connect and how to build all the experiments. So yeah, that was a tough course, but I had a really good lab partner, which helps out a bit. That's a big tip to anyone who is maybe not the most hands-on person in a lab class. Pair up with someone who is. You will thank yourself much later. Okay, next up we have Chem for physicists. And as the name suggests, it's a chemistry course, and it was like in a span of 3 weeks. So both of these classes were like in a span of 3 to 4 weeks, not over like a full quarter. So there was like a lot of information coming at us really quickly. And the chemistry we learned was essentially from like the first 2 terms of a general chemistry course. So we learned stuff like Lewis dot structures, molecular orbital theory, went over acid-base reactions, and stuff of that nature. I don't remember too much of it, but what I do remember from this class is that we would read technical papers and we would have to discuss them as a class, and we would be tasked with sort of summarizing them and getting the main points and just really analyzing the paper from an outside perspective, which is really helpful. And I take that skill with me to this very day when I read papers. So I think, if anything, from this class, I gained that skill of how to really critically read a scientific paper. And I'm super grateful for the professor for teaching me that. So yeah, that was the summer of 2017. And now we can actually get into the actual fall of 2017. So the first course here is Quantum Mechanics. It's Quantum Mechanics 1. The main book we used was Lectures on Quantum Mechanics by Gordon Boehm, and we had 0 homeworks, 0 midterms, and 1 take-home final for our entire grade. So there was a lot of pressure in that course. It was nice to not have to do any homework. There was some optional homework that our professor would give us saying, hey, you should probably do this if you want to stay up to date with the lectures. But I'm going to be honest, I don't think that many people did them, but maybe I'm just speaking just for my own sake. The content in that course covered stuff like, photon polarizations, learn about Dirac notation formalism, Schrodinger equation in 1D, Heisenberg equations of motion, all sort of standard stuff that you would see in an undergrad quantum mechanics class, but maybe at a little bit more higher level of mathematical sophistication. We got into a bit of perturbation theory, but we also saw some new things too, like the Feynman path integral for the first time, which was really cool, but also really, really complicated. I think what made this course hard for me was that it was the first time where I was really applying some mathematical techniques and concepts like Green's functions, using like spherical Bezel equations. Those things were super new and foreign to me at the time, which was kind of scary. But I was actually thankful because I don't think any of that stuff ended up being on the final, which is why I ended up getting an A in that course, because the final was surprisingly, I think, easy compared to the stuff that could have been on it. So perhaps I just got lucky that class. But regardless, moving on. The next one we have is a Continuum Mechanics course. Now, Continuum Mechanics actually substituted a standard classical mechanics class for me. So normally in grad school, you'd be taking like Goldstein classical mechanics, which is what my peers took. But because I was in the chemical and materials physics program, I ended up doing Continuum Mechanics instead. And so for Continuum Mechanics, it's essentially a combination of solid mechanics and fluid mechanics. We use this textbook known as The Physics of Continuous Matter by, I think his last name is Lautrup. And we did a lot of vector calculus and Cartesian tensor analysis, because that's really what a lot of solid and fluid mechanical descriptions are about. You have to cover concepts such as stresses and strains, Young's modulus, elasticity of materials, which essentially describes mathematically, how solid materials will bend and deform when you stretch them and flex them in different directions. And on the fluid side of things, we covered concepts such as like the Bernoulli's equation, hydrostatic equilibrium, drag, viscosity, of course the Navier-Stokes equations, and just basically trying to understand the motions of fluids like water and gas at rest and as well as in motion. Fluid mechanics kind of has this like bad reputation if you ask like engineering students, because I think it's just taught really difficultly from every engineering student I ever heard from, but I found it very interesting, if not for just its mathematical framework. But the thing about this class was that it was completely done in Mathematica. So we essentially were given lecture notes in Mathematica, where a professor just had a Mathematica notebook that had all of the equations written out in Mathematica, and all of our work, our homework, would be submitted on Mathematica notebooks. So all of our problems were done on the computer. So there was no real handwriting of the work. It was all learning how to use Mathematica to solve these problems, which was really cool. Though I think if I could go back, I probably would take more notes by hand, because I feel like my knowledge of solid and fluid mechanics is all contained in those Mathematica notebooks that I haven't opened in like a year and a half at the very, very earliest. So overall, very solid course. Had 7 homeworks and a final. The final exam was like 10 questions or something. And yeah, it was just like another homework assignment. It didn't really deviate from any of the other homework assignments besides just having a bunch of problems that span the entire course. Next up, we have Computational Methods, which is a course that's all in Mathematica, and surprise, surprise, it was taught by the same person who taught Continuum Mechanics. So I had that same professor twice. And essentially in that class, we just used Mathematica, just like we did in the Continuum Mechanics class. So I got a lot of Mathematica that quarter. We didn't really have a textbook, but we used this thing known as the Mathematica Handbook, which is something the professor actually designed for Mathematica. It's like a additional add-on to the normal software program, and it's essentially just like a library of Mathematica notebooks of different mathematical concepts. So we were essentially taught in that course to apply Mathematica to solve scientific problems. So we covered a lot of different math concepts and applied them to physical problems. So the math concepts span over like vector calculus, linear algebra, differential equations, complex variables, contour integration, which is really, really awesome. I love contour integration, probability, Markov chain Monte Carlo methods. And I think this course was super cool because it was sort of taking all of the math I had learned in my applied math minor and then just teaching us how to do it in Mathematica. So it was a really good refresher for me as someone who had just actually spent the whole last year of my undergrad the year before doing applied math. Here I was applying more math to physics. So I think that really bolstered my applied math sense. Though, to be honest, again, this was one of the last times I really had a chance to flex that sense. So let's go ahead and move on to the winter of 2018. So the winter of 2018 was quite the quarter because we had 3 core physics classes coming at me this quarter. We had Electromagnetic Theory, Statistical Physics, and Quantum Mechanics 2. Okay, so I actually have here on my list, I've written down Quantum Mechanics 2 first, so I guess I'll just talk about that since it's on my list. And Quantum Mechanics 2 is just a continuation of Quantum Mechanics 1, as you probably could have guessed from the name. And this book we used for this class was Modern Quantum Mechanics by J.J. Sakurai, so we actually switched books between the 2 courses, though both those books covered roughly the same things, but it was kind of a weird shift. Now, this class actually had homework in comparison to the last quantum mechanics class. So we had 6 homeworks, we had a take-home midterm, and an in-class final for this course. And what we covered in this course was time-independent and dependent perturbation theory. We covered the addition of angular momentum, symmetries, and conservation laws in quantum mechanics, gauge transformations, and my favorite concept of all, Clebsch-Gordon coefficients. If you can't tell I'm being sarcastic, then I'm being sarcastic. I really hate Clebsch-Gordon coefficients. If you ever had to calculate a Clebsch-Gordon coefficient, you know how painful it can be. So yeah, I really hated that. I never want to calculate another Clebsch-Gordon coefficient in my life if I can help it. So that course was it was tough, man. I mean, there was a lot of new things in quantum I had never seen before, especially with like the gauge theory stuff, and there was also a bit of group theory in there as well. So yeah, really intimidating stuff, and I'm glad I got out with an A-, because honestly, I don't even, it was all a blur. It was really all a blur. The whole quarter was a blur, but that's beyond the point. Okay, so next up on my list, we have electromagnetic theory. So now I'll talk about this. I'm going in this weird order, but whatever. So electromagnetic theory is the Jackson electrodynamics course. So we use Classical Electrodynamics by J.D. Jackson, that infamous physics textbook that everyone fears. And this course we had 8 homework assignments. We had 1 in-class midterm and 1 in-class final. So for the homework, we got paired in groups of 3 or 4, and we all would essentially do 1 problem that week from the set. So the problem sets were usually 3 to 4 problems long, and we would just come up with a system of everyone just picks 1 problem to do for that week. We would pool all our work together in 1 document, and we would submit it as 1 document that would get 1 grade from the professor. Now, it was nice because that lessened the load of the homework, but we also would be able to see how everyone else thought of how to do each problem, and we could, comment on each other's works and say, hey, I think you missed a minus sign here, you're missing a factor of 2 there, stuff of that nature, where we really had to be honest and look at each other's work before we submitted the final assignment, because it was all of our grades, not just any individual person's grade. Jackson E&M's course covered stuff in electrostatics. It covered Laplace's and Poisson's equations, boundary value problems, very, very similar stuff you might see in a Griffiths electrodynamics class, but at a more advanced level, because you're going to be using things like Green's functions that I don't think was really used in a Griffiths class at all. We also learned about, of course, dielectrics, magnetostatics, and a brief introduction into radiation theory. I mainly remember, out of all those things in this class, how to use the spherical harmonics. I just remember our professor always giving us problems where it usually came down to just knowing which spherical harmonic was the right spherical harmonic to use for that class. There's like a whole page in Jackson giving you like the first several spherical harmonics, and I just remember bookmarking that page. But the funny thing is, by the end of the course, I didn't even need to look at the page. I just like knew off the top of my head like what is y10 and what is y12 and stuff like that. So okay, next up we have statistical physics. So this course was actually taught by the same professor who taught Quantum Mechanics 1 the previous quarter. So again, like before, we had 0 homeworks, 0 midterms, and 1 take-home final that was worth 100% of our grade. Now, statistical physics was interesting for me because I actually had to miss half of the courses in this entire term because I switched out of the chemical and materials physics program. My teaching assignment had already been assigned, and by the time I wanted to switch out of the program, I had to take a different statistical physics class. So this was actually not the class I started off the quarter with in statistical physics. I was taking a class in the chemistry department, then I ended up switching to this. And when I made that switch, this course interfered with one of my teaching assignment sections, so I had to miss this course once a week out of every 2 lectures. So 1 out of every 2 lectures I could not attend. And I'm very grateful for the people who took notes for me and would share their notes with me, because I'd have no idea what I'd be doing without their help. So thank you guys. And because of your help, I got an A- in the course. Yeah, again, having a 100% take-home final is nice in principle, but also terrifying if you don't know how to do any of the problems. Thankfully, I did know how to do some of the problems, but I remember messing up on one. I had to do some partition function that I think I just blew. I just didn't know how to drive it or something. But I don't care. I got an A-, and I'm happy with that. Oh, I should mention, before I forget, we used for this class Statistical Mechanics by Patheria and Beal. And again, before you guys forget, all the books and their links are going to be in the description below, so check them out if you are interested in the material. Moving on to the spring quarter of 2018, where I took my first ever astrophysics classes in my entire life. That was very exciting. This was a very, very exciting moment for me because I did no astrophysics in undergrad. So to have this opportunity to study it in graduate school was just super exciting. And this class, Galactic Astrophysics, was taught by my PhD advisor. So this was before he fully accepted me as his student. We were sort of like in the process of agreeing to work together, but he hadn't officially, I guess, accepted me into the group. So I felt kind of, felt the pressure to do well. And I think I did fairly well in that class, given my A. And this class was really fun. I really liked this class. I learned so much astrophysics in this class. And you think it's a class of just all on galaxies because it says galactic, but we learned so much in that course. Like, the purpose of the class was to essentially help build as large of an astrophysics knowledge base as possible. So the 2 main books we used for this class were Galaxies in the Universe by Spark and Gallagher, which was like the main text. And then we also used Galactic Astronomy by Binney and Merrifield, which was a supplementary text, but also just extremely vital and useful because it just had like so much information. That's one of my favorite books to this day. It's on my shelf up there. I really love Galactic Astronomy, even if it is 23 years old this year. But anyways, in this course, we ended up covering stuff like the magnitude system in astronomy, telescope filters, extinction and reddening, radiation by dust, different coordinate systems in astronomy, stellar binary systems, transiting exoplanet systems, spectral lines, processes in stellar evolution, luminosity functions, initial mass functions, structure and dynamics of the Milky Way and its different components, and an introduction to stellar dynamics. It was a lot. That sounds like a lot, doesn't it? I'm really grateful for my advisor for this course because it it just really like threw all of the astrophysics that I wish I had learned as an undergraduate, or maybe most of it, and did its best to condense it in a 10-week period. And I think it did a very, very good job. I feel like I left that course feeling like I know something about astrophysics now. And that course, we only had 4 homework assignments. We had no midterms or finals, but we'd also had to edit a Wikipedia article for the course, which was really fun because our advisor was saying that a lot of astronomy Wikipedia articles are actually not very well written. So we were tasked with picking a Wikipedia astronomy article of our choosing and then editing it and submitting it as an assignment. And so I ended up picking stellar dynamics as the Wikipedia article that I would edit. And I'm going to put a link to that article in the description if you really want to read more about stellar dynamics. It was I think, a significant upgrade from what was previously there. So check it out if you're interested. Next up, we have Extragalactic Astrophysics. So this is another astrophysics class that I took. And this class used the book, I believe, Extragalactic Astronomy and Cosmology by Peter Schneider, second edition, if I'm not mistaken. And we had 1 homework assignment, we had a presentation for a midterm grade, and we had an oral final exam where essentially the professor could just essentially ask us anything from the course, and we would have to just sort of talk about it and write on the whiteboard what we remembered from that topic. And I don't remember even being allowed to have any notes or my book. So that was really intimidating, just being asked to explain any given topic from a class on the spot. But I ended up doing okay, I think, because I ended up getting an A- at the very least. So in this course, we covered concepts like types of galaxies, dark matter profiles, observed relationships in galaxies, such as like the Tully-Fisher relation and the fundamental plane, covered galaxy luminosity functions, stellar dynamics, Jeans equations, and some basic stuff about the expanding universe. So again, very useful course for me as someone who had never taken any of this stuff before. And that concluded my first year in grad school in terms of courses. Moving on, in fall quarter of 2018, so this is the first quarter of my second year in grad school, I took 1 course. I just took Cosmology. And Cosmology was a class where we used the book Modern Cosmology by Scott Dodelson. It actually got an update this past year, and I kind of want to get a copy for myself because I have the first edition, but I kind of want to know what the second edition has to offer. We had 5 homework assignments that were brutal. I remember those assignments taking a long time to do because they had multiple parts in them. We didn't have a midterm, and we did have a final. So no midterms, 1 final in class. And we covered in this course the basics of the expanding universe, Friedmann equations, the cosmic microwave background, Big Bang nucleosynthesis, evolution of small perturbations over time, and also covered a bit of general relativity as well to understand all of this happening. So it was the first course where I was really using general relativity and applying it to something. That was really, really cool. The professor was awesome. I really loved this class because he would just go on these topics and like kind of like on a tangent, but like it's like I just wanted to listen to him talk because he was just so knowledgeable about this subject. So very, very grateful I had him as a professor. I think he really knew his stuff, and he was tough, but I don't think you can really complain when you learn a lot from a professor. So yeah, overall, I loved it. I ended up getting an A. Was really happy about that. And yeah, that was my fall quarter of 2018. Next up, we have 2019 winter quarter, and it says here special particle physics course. Now this course changes every year, so the topic can change, but this specific term, it was machine learning and statistics as applied to physics. So a very, very interesting and modern course in the subject. And we didn't have any textbook or anything. We just learned out of these Jupyter notebooks that our professor had written up. Our homeworks were all in Jupyter notebooks that we had to submit. There was no midterm and there was no final, so it was just homework, which was kind of nice. And the topics that we learned were tensor computing, a little bit of probability theory and Bayesian statistics, went over Markov chain, Monte Carlo algorithms, and an introduction to neural networks and deep learning algorithms, which, again, like I said, is a very, very modern subject and super, super interesting. I kind of wish I was using this stuff in my own research nowadays. I don't do any machine learning at all in my own research, but I think just having the knowledge of sort of what it does and how the things you could possibly apply it to was a good enough reason for me to just take the course itself. So in the 2019 spring quarter, I took, again, just one course. I took Radiative Processes, and the book for this course was Radiative Processes in Astrophysics by Rybicki and Lightman. It is like the textbook of the subject in the field. It's been around since like the 1970s. In this class, we had 5 homework assignments, no midterms, and 1 final exam. In this course, we learned about various processes and interactions between matter and radiation in space, like Compton scattering, Thomson scattering, Bremsstrahlung, the Sunyaev-Zeldovich effect, synchrotron radiation, and just all about radiation and matter, really. What more can I say? The final exam that course was pretty brutal. In the final exam, we couldn't use our textbook, which I haven't mentioned this before, but we were able to use our textbook in pretty much all of the courses where I had a final in grad school. So this was like the first class, I think, where we weren't allowed to use a textbook in our final just to like look through in class. So that was pretty rough, if I'm going to be honest, because I think I had guessed what topics were going to be on the final and I just completely guessed wrong and I thought I bombed it, but I guess I didn't bomb it too badly because I ended up getting an A-. So yeah, even if you bomb it, you can still get an A-, kids. That's the lesson here, I suppose. I don't know if that's really a lesson I want to preach, but that's just my experience. And lastly, we're going to go to the 2019 fall quarter, which is the last quarter I took any classes at all. And the course I took was Stellar Astrophysics. The book we used was Stellar Interiors, Physical Principles, Structure, and Evolution by Hansen, Qualler, and Trimble. We had 5 homework assignments, 0 midterms, and 1 final presentation. So not a final exam, but a final presentation. And it's like your standard astrophysics course in stars. It's you cover the equations of stellar structure and evolution, you go through the virial theorem, talk about energy transport in stars, get into Hertzsprung-Russell diagrams, talk about different types of stellar remnants like white dwarfs and neutron stars. And we got into the basics of nuclear physics and the processes and the nuclear reaction rates that are associated with nuclear energy. So very standard stuff, but I'm happy I took it because I think I've always been interested by stars, and it was the first time where we really just got to think about the stars themselves. In the previous astrophysics courses like Extragalactic and Galactic Astrophysics, we did talk about stars, but they would just be sort of in passing, and we wouldn't really go into the fine details of what the thermonuclear fusion processes were like in stars. So again, really interesting stuff, and I'm super happy that I have it now in my arsenal as an astrophysics student. And that is essentially the last course I took for credit. Now, it may not be the last course at all in grad school. I'm thinking about taking possibly a high energy physics class because it would essentially be the only class where I'll have learned anything about particle physics because as you can see, I took no particle physics courses. And another course I'm interested in taking is general relativity. Unfortunately, that class has sort of had an issue with being taught at my institution over the past couple of years just because the person who taught it for the longest time ended up retiring. So it's sort of in a stage of flux right now. But I'm thinking about taking that course in the future as well. So yeah, that is essentially my coursework that I've gone through so far in grad school. I know this must be a pretty long video like the video I made for my undergraduate physics degree, but I had a lot of fun talking about it. And I'm curious to know if you guys are studying physics or astrophysics, if this looks anything at all like your curriculum that you've taken as a student. And if so, leave a comment below. I'm really curious to learn more. Anyways, I hope you guys enjoyed this video. I hope you guys will tune in for more videos like this. And just make sure to like, comment, and subscribe, and I will be seeing you guys in the future. Have a good one, everyone.